for homework is we're going to set up the graph that we have to make. So it says step 6, procedure 6 says to create a 6-point scatter plot graph. Forget about this part. Do not include the last row. We are going to plot the last row. You determine the variables and on which axis they should go. Once complete, add a curved trend line to your graph. So to make life simple, what we're going to do is we're going to take our graph paper and we're just going to pull it off the back here so that we don't have to keep flipping back and forth. All right, so we have, this is our graph area. So when you think about graphing, you think about the independent variable, which is what you had control of, and the dependent variable, which is the data that you're collecting. The dependent variable responds to the independent variable that you changed. So what did you control? What did you change? Well, I think that we can all agree that we were in charge of the mass. So this is our independent variable. And then what is the dependent variable? What did you then wait a minute or two and then read? What did you measure? What was the data that you collected? Well, you were leaning over and you were reading the air volume in the syringe. So we're going to plot the total mass versus the air volume in the syringe. So where does the independent variable get plotted on a graph? Where should we put the independent variable? Do we plot the independent variable on the x-axis or on the y-axis? Where does the independent variable go? Well, the independent variable always goes on the x-axis. So what we're going to write down here is the total mass, and the unit of measure for total mass was what? It was in grams. And then the dependent variable always gets plotted on the y-axis. So over here, we're going to write air volume in syringe. Syringe is SYRINGE. And that was measured in milliliters. That's what the unit of measure was. So this is an example of where both axes will start at 0. So we're going to put in our origin, we're going to put 0, 0 down here. And since we have mass that ranges from 0 to 2400, and it looks like there's 30 some odd lines here, we're going to, each line on this axis is going to be 100 grams. We don't have to plot every one. So 1, 2, 3, 4, we're going to make a mark. 5, this is 500 grams. 1, 2, 3, 4, 5, this is going to be 1,000 grams. 1, 2, 3, 4, 5, this is 1,500 grams. 1, 2, 3, 4, 5, this is 2,000 grams. 1, 2, 3, 4, 5. 2,500. 1, 2, 3, 4, 5. This is 3,000. 1, 2, 3, 4, 5. We get up to 3,500. Now I know that's more mass than we use, but this is good because we're going to be able to extend the graph to estimate what can happen if we put more mass on. And then as I was walking around, I noticed that people got down, I should say, to 23 milliliters, but we have to go up to 30. We have to go up to 30 milliliters. So it just makes sense that each line on the line graph is worth 1. Okay, so again, we're at 1, 2, 3, 4, 5. This is 5 mil, 5 mil. 1, 2, 3, 4, 5. This is 10. 1, 2, 3, 4, 5. This is 15. 1, 2, 3, 4, 5. This is 20. Make sure you make these tick marks so that you know which line the number is associated with. These tick marks are important. 1, 2, 3, 4, 5. It's 30. 1, 2, 3, 4, 5. 35. 1, 2, 3, 4, 5. 40. Now I know we didn't get up to 35, 40, 45. 1, 2, 3, 4, 5. But it's important that you complete the graph. 1, 2, 3, 4, 5, and it goes up to 50. So if you plotted this correct, you should get up to 50. All right. Now what I want you to do is in pencil, I want you to plot 1, 2, 3, 4, 5, 6. You're gonna have 6 plot points. Okay. So 0, 30, 200, whatever you got, 400, whatever you got, 900, okay? 6 plot points. You don't have to connect them. I just want you to plot them. That's what I want you to do. And I also want you to give this graph a title, whatever you think the title should be, in pencil, so that if there are any errors in plotting, we can correct them tomorrow. So that's your scale, and I want you to plot your 6 data points. All right, I'll see you tomorrow. Have a good night. Bye.